Hi, so today we're going to talk about how to classify triangles. Triangles are the most basic figure in geometry because they're the most basic polygon. They have the least number of sides and angles that a polygon could possibly have, three, right? It's impossible to make a polygon with two sides or two angles or one. Um, so So this is our most basic polygon. And we can classify or identify triangles in two different ways. The first way is by its angles, all right? And the angle, of course, is the space between two sides, right? It's what is formed when two rays or two sides meet at a vertex. That's your angle. So we're looking like right here, like they're corners, okay? So we can classify them in three different ways by angles. An acute triangle is one in which all three angles are acute. All three angles have to be acute for the triangle itself to be acute. Remember that acute means less than 90 degrees. An obtuse triangle is one in which the triangle has exactly one obtuse angle. So we can see this triangle right here. Here is our obtuse angle. It is wider than 90 degrees. Now it's impossible for a triangle to have more than one obtuse angle. It would be impossible for all three sides to meet at three different vertexes. And finally, there's the right triangle. That's one that has exactly one right angle. So you can see in the triangle here at the bottom left corner is a right angle. It's a perfect corner. And once again, it's impossible for a triangle to have more than one right angle. All right, so those are the three classifications by angle. So we're going to practice. All right, now these three triangles don't have any angle measurements or markings for you, but we can kind of eyeball it. Usually when we're doing geometry, I would tell my kids, don't eyeball it, use the markings they give you. Since we don't have any here, we're just going to give it our best. So this triangle, if we look at all three of our angles, all three of these angles look to me like they're less than 90 degrees. I don't see any angle that is 90 or greater, so we're going to call this an acute triangle. All right, this triangle right here, this angle looks pretty wide. All right, if I would lay a protractor on it to measure it, I'm sure it would give me something greater than 90 degrees. That probably looks like it's about 95 or 100 degrees. All right, so this would be an obtuse angle or an obtuse triangle. Okay, this triangle down here has an interesting marking. If we look in the corner right here, we see a little box. In geometry, this box is used to indicate a 90-degree angle. So that makes this a right triangle. All right, and finally, this triangle over here, um, if we were trying to eyeball this, we might get it wrong because this angle looks to be 90 degrees, but if you look closely, or if you use a protractor, you'll find out that it is just slightly less than 90 degrees. It's probably about 85, somewhere between 85 and 90, but not quite 90. So this is going to be an acute triangle because all three angles are less than 90 degrees. The second way we can classify triangles is by their sides, all right, and the measurements of their sides. So here are the three classifications based on side. We've got equilateral triangles, and those are ones in which all the sides are the same measurement, all right? So this triangle uses slash marks. A lot of the times in geometry, you'll see these like hash marks to identify the sides of the triangle they're all the same. If they all have the same hash mark, they're all the same measurement. And it really doesn't matter um, how big they are. You know, they might be an inch, they might be 23 feet, but all three sides of this triangle are exactly the same. So that makes it equilateral. Isosceles triangles are one in which exactly two sides are the same, so no more and no less. So here we see these two sides have the same hash mark. That means they're the same size. But this side does not have that hash mark. So it's different. It's not the same. That makes this an isosceles triangle. Finally, this triangle down here at the bottom is what's known as a scalene triangle. None of the sides are the same. We see they all three have three different style hash marks. That means they all measure something different. So that's a scalene triangle. All right, we're going to practice naming these triangles by their sides. So looking at this triangle, we have a hash mark here that matches this hash mark here. So these two sides of this triangle both have the same hash mark, but this one does not. So that means that these two sides are the same, but this one is not. That makes this an isosceles triangle. I'm going to abbreviate. This is an isosceles triangle. Over here we have three matching sides. All three sides of this triangle are the same. They all three have the same hash mark. So I'm going to name this an equilateral triangle. Coming down here, this triangle has, again, two sides with the same marking and a third side that is different. So this is an isosceles triangle. And last, this triangle over here we were missing something. So this triangle right here has three sides that are all different. They do not match. They are not the same size. They don't have the same hash markings. So this is a scalene triangle. Okay, that's it for this video.